we dive in the next presentation, and after that we'll have a short coffee break. So right now I would like to present our friend Bernd Wunderlich. He's going to tell us what to do and what not to do with artificial intelligence. Let's hear it from him.
So first of all, let me ask you a question. Who of you knows Gartner? Okay, so almost everyone, I think. So Gartner, anyways, is a leading analyst firm in IT. And there are a lot of companies, at least the IT departments, that really listen to Gartner, that listen to Gartner predictions, that buy basically with our Magic Quadrants, that buy from the vendors' technologies, and that really listen to us how they should implement all of this. So a little bit to myself, I'm actually in Gartner consulting, and what I do is basically I support companies implementing strategies for how they should implement AI, for how they should implement digital transformation, how can they scale with this. And I'm focused at the moment in the manufacturing market, where I support big manufacturers on how they can basically implement the next level of automation in their factories using technologies such as IoT and AI. And I'm focused with some of the largest manufacturers, and they have really the vision that with all of this new technology, they can fully automate the manufacturing plant, and basically that in 10, 20 years from now, that there will be basically no more people working there who do things manually in the plants. So a little bit to myself, I started actually with AI at my university, and I worked with a system similar to this one, and the system was called Navis. We implemented basically a neural network, a machine learning algorithm. We connected these that kind of robot with the two cameras, and we applied stereo vision basically for measuring how far an object was in front of this robot, and that got actually used in recycling of cars and recycling of waste, this project later on. But it was basically before the AI winter that was there in the 90s. So this was like in 95 when I started with that, and we had actually we programmed on transputers. These were parallel computers, which were really heavy to program with a separate language called Occam, and so this was my first experience with that. And then later on, when I joined, then or when I was working for IBM, I basically got to know a little bit of Watson and also of Watson IoT. So today I'm going to present you a little bit about the Gartner definition of AI and what you can do, what we recommend you to do, and where AI is basically applied. So I hope I can tell you still some new things about it, since we are a little late in the day. I hope that is still possible. So first of all, we had in Gartner a very long discussion whether we should define at all AI or not, and how we can define it. And the very short version you can find here. We have identified or defined AI as projects that grant organizations the superpowers to classify and predict in ways workers cannot achieve alone. So we see in AI basically that today support workers, but also we see basically some standard processes, some standard tasks can be replaced by AI. By the way, Gartner does not predict that AI will replace jobs, but it will rather generate jobs. And this is also a prediction that we give. And we predict basically that by 2020, 30% of the CIOs will include AI in the top 5 investment priorities. And that basically 30% of the new development projects will have AI components included, and basically will be in joint teams implemented by data scientists and programmers. So we see AI, we will see AI in all of the software applications that are offered today by the software vendors, but it takes some time. And here is a prediction by 2020. So at the moment, AI is still in infancy stage, basically in the enterprises. And there are a lot of basically explorative projects are happening. But we also see that, for example, 85% of the projects, they never leave this exploratory stage. So it's really the biggest challenge that enterprises today have really is this thing, how can we scale this and how can we make this real? And so this is some of the definitions that our customers give when we talk about them. So a lot of focus is actually on automation and on increased performance, and so that they would like to get some operational savings out of it, and to really focus on automation of processes, on automation of some tasks, and so on. We say AI is not simply that, but AI is a lot more. So here, and I think we have all heard about this also today already, but in 2016 a major step was done by Google DeepMind that beat basically the world's greatest Go player, and it achieved it by basically applying reinforcement learning and by applying self-testing. So it really learned on its own and basically got better and better by using these technologies. And so here's our larger definition of AI, basically. So AI is a technology that can emulate human performance. Typically, some learning is applied in this. It comes out with its own conclusions, so not just what is programmed, basically. It understands complex content, such as like data, and can also basically hopefully improve the quality of the data, which is still really one of the biggest challenges today, that quite often the data quality is not as good, so that you can at all apply AI, or basically the data is sitting in different silos. So you make AI, before you can work on AI, you really need to clean your data, and you put like 80% of the time basically in making your data better rather than focusing on AI. AI then also engages in natural dialogues with people, and AI enhances the cognitive performance of humans. So we have seen that basically some performance was succeeded by various AI vendors, such as for like visual recognition and so on. And we state here that it can replace people in execution of some non-routine tasks. So when we see here AI, we have seen this AI concepts from the like 1960s on. There it was mainly focused on some research. We had then also this AI winter, which actually came in the 90s. but we have the focus here was first of all on supervised learning. We had then followed the unsupervised learning, and then also the reinforcement learning. So within reinforcement learning, you can basically, we in IBM actually, it was used to basically to train a robot that was performing like a new task, and we could there, by using reinforcement learning, speed up this programming of the robot very significantly. They could have also programmed it, but it would have taken way more time to do so. And so that is also solved then by AI. We see in Gartner basically today all of this narrow AI. So narrow AI is the definition basically that it works on one specific task, so within a certain industry or within a certain process, and can help you improve this process. We don't see yet, and there were various attempts also to get a general AI going. Those attempts so far have failed, and with general AI, we basically say it needs to have to solve more than like one task, so really has some near human level of intelligence, but could solve like here we say basically any problem, and so that we will not see in the next few years coming up. So the focus is still really here on the narrow AI. And so we have here basically the artificial intelligence and the definition of machine learning and deep learning. So deep learning is basically one machine learning method that is inspired by the biology of the human brain. So even when I did in the 90s here, when we worked on the neural network to program this Navis robot, we were very much inspired by the human brain. So we took a look at how the human brain works with the synapses, and then built this up. With that Navis system, it was like stereo seeing in order to solve that. So we see AI pretty much on physical objects as well as on virtual objects, so software basically. And I would like to state actually the vision of Grady Booch. Grady Booch is an IBM fellow, and Grady is the inventor of UML. He has a 20-year vision basically for AI. He would like to support the launch of the Mars, and he says basically if we do this, then really this computer needs to self-learn on the way of flying there. And he, by the way, we had in the previous presentation, we have the ROS middleware. So he came up with a self middleware, which is basically used or can be used on all of the objects that we have. And he sees basically that we have AI pretty much in every object that we have, even in a mirror or in a shirt or whatever you have. So today we see basically AI going out to the physical objects and going out to the world, where we have existing objects such as like consumer appliances, where the appliances maybe can talk to each other, so can say basically turn off or turn on the ventilation system if we cook something which creates a lot of dust, or like also in industrial equipment, where then the AI can focus on optimizing that equipment, optimizing the maintenance cycles of that equipment, but also how equipment is used basically within a process, also with the medical devices. Then we have AI as well on new physical objects, such as on like the robots, where we see more and more intelligent robots coming out. So the humanoid robots, but also industrial robots that today have the challenge. If you program a robot, you basically use it then for 20 years, but it's really, really difficult to reprogram it. And so with AI, you can, if you apply the reinforcement learning, you can do this much quicker. And also on, of course, on autonomous vehicles, and there was the example that we saw before, where basically you apply AI to process the radar, to process the LiDAR sensors, basically to apply sensor fusion within the car, and basically you can then decide whether a car should stop in front of an object or not. And then also, of course, on the virtual objects, so on packaged applications, on custom applications, but also then the new things that are coming out with chatbots and advisors, virtual assistants, and so on. And we at Gartner, we predict basically that also by 2020, you will have, or people will converse more with the virtual assistants than actually with the people within companies. And so I'm Gartner, so I need to present some of the key research here that Gartner publishes. And so we can see here the hype cycle that was published last year for AI. And on this hype cycle, the interesting thing is basically that AI is at the moment really, there is a lot of hype created about it. It's one of the most hyped technologies that we see out here. And basically to explain you a little bit of the hype cycle, we see basically we put only commercially available technology on this hype cycle. So you can, whatever you see on here, buy commercially on the market by a software vendor today. We have here basically the adoption. So here, for example, for the general artificial intelligence, we say it will take over 10 years until it is here, basically in the plateau of productivity, where it's basically used by 85% of the companies in a particular industry. And so we predict, and we predict this basically also by the number of questions that we get from customers. And AI is at the moment the most hyped technology because we really get a lot of customer questions about it. And so here we can see, for example, at the moment we have deep learning, which is on top of the hype cycle here, so the most hyped technology together with machine learning. And here we predict that it will take like 2 to 5 years only until it reaches the plateau, until really 85% of the companies have adopted this in some form. What is interesting about this is also that when you are here and you adopt the technology, then you can really differentiate against your competition. In this, once you reach this plateau, it will be more and more difficult then, because like 85% have basically implemented this already. And so what we see today where AI is typically used is to improve the speed and efficiency of processes within companies, and so that staff is better utilized. I heard a statement once that basically we need really AI in order to solve the problem of the email, of the floats of email that we get today. So we really need a bot in order to answer the standard emails that we get in today, and so that help us basically to improve our efficiency, and so that we don't run into a burnout problem. Then also, of course, to reduce operating costs and increase operating efficiencies, to better process the data with analytics, and we've heard the example of machine learning applied for predictive maintenance today already a number of times. Also, AI is used for enhancing customer experience and engagement, so really in customer care and service desk optimization, although we have heard a number of examples in the market where companies try to leverage AI for doing this, and they've massively failed of automating basically the service desk using AI. So retail companies to really be cautious if they go and implement a massive AI project, for example, for their customer care and for the service desk. So here we have actually we had a questionnaire where we have like 80 customers basically answered that, and the answer here was basically what type of AI applications has the organization integrated or plan to integrate with existing applications or solutions. And here the focus was heavily on customer engagement applications, and also on call center service and support. So those three together, like with digital marketing, rank among the top three where AI is today used. And basically we predict that by 2020 that retailers will use artificial intelligence to accelerate the human decision making well beyond the current levels. So to help basically retailers to help sales and marketing to customize the sales process, but also to personalize the communication way beyond the current levels. I'm wondering how now GDPR will play against that, basically, because the customers really now, or enterprises, need to implement GDPR, and they cannot store this personalized data automatically anymore how they used to do this. So the customer really needs to agree to this. And of course this could then lower the speed for this adoption. Also, we have seen that AI is used in a service. The biggest problem today is basically that companies are not transforming their internal processes that quickly. So you can basically connect a product which is out in the market easily. You can also do this, implement predictive maintenance and repair. But the key thing is that the customers or the enterprises, they also need to transform all of their processes so that they leverage this data and that they can then really optimize the processes at all. So with AI and combined with IoT, there are a lot of potentials behind it, but the key problem is today for me that really companies need to transform, and they also need to find ways in order to scale this, and they need to be willing to basically to transform themselves, their organizations, but also their ecosystems together with their partners, need to find agreements of this. And we see today the biggest hurdles actually to implementing all of this is in the lack of necessary skills. So we have here 54% basically of these people who participated in this request answered that the lack of necessary staff skills is the biggest challenge basically in the adoption of AI. And surprisingly to me was that only 23% answered that how they can get the value from AI, so determining how they can measure the value from AI in this question. And so this was my presentation. Which questions do you have? Okay.
I wanted to ask about the title, so I didn't really get from the presentation what we should not do with AI.
Yeah, I mean, I think I gave you some examples what you should do. Yeah? What you should not do is basically you should not try to boil the ocean with AI. So to try to solve everything. For example, we say you should take care really if a vendor approaches you, if you are an enterprise and a vendor approaches you and says we can fully automate your customer care with using AI, you should be very cautious. Yeah, because these are typically like 100 million plus projects, yeah, and that is typically is then the value is not achieved. So and AI is still in infancy; it's still being massively developed, the technology, and that you need to understand if you are an enterprise. And this is basically what we recommend. So take really this as an experiment with it, try it out, but don't try to boil the ocean and commit to a very big project, very big AI project. Okay.
Would you predict a big divide especially between the markets of the EU and China and the US? With regards to investment and regulatory issues, or would you say that probably companies will be able to overcome this?
So the question is with regulatory issues, and the question is also then with investments into AI. I mean, we have heard that basically China is investing a lot in this. We have also we see basically on a weekly basis startups popping up, especially in the US, but all over the place. Yeah? I mean, I think from the regulation, I mean, in Germany you have like the industrial manufacturers, yeah, which are really driving it. The problem that we have as Europeans is basically that we don't have a cloud infrastructure. So we just don't have an infrastructure as a service player, a big one, and so Amazon and Azure, they can really win this race to the bottom, yeah, and by scalability, and this is really what cloud computing is really all about. So we see this duopoly of the two players, and they can really go down in the price, yeah, where like an SAP, for example, can just not compete on that level. And we see a lot of players from China as well going into cloud computing still. There's lots and lots of investment behind it. And we don't see a similar investment at the moment in Europe. Yeah, but I think especially Germany has a big chance to drive this from the manufacturing play and not from the consumer play.
When you say Germany don't have that cloud business, do you mean by that there's no German company doing that, or that they don't have like those server farms?
Yeah. No.
Microsoft has German cloud and also the European cloud. The European prices, or there's security stuff, which still is there in the German type of cloud.
No, I mean basically there is no German infrastructure as a service player out there that can really compete, and it's all this duopoly at the moment. And I mean I learned basically in cloud it's all about this scalability. So and I currently see the two winning every game. And this is the difficulty with it when we talk about, I mean, on the application layer, of course, it's a different story, but we don't know exactly how it will turn out in the next few years, how also this, all of the political battles and data privacy and so on will turn out. And so there are definitely some risks. I also work together with companies who have big questions about the Cloud Act, what they should do with that, but they simply don't have a chance. Yeah? So they need to go at the moment with the American companies.
Yeah, I have a question, because you said artificial intelligence is predicts and classify more or less, but I'm wondering where the action plays a role here in artificial intelligence in next year. So you don't need only to predict, but you want to also make actions, make decisions and actions. And my question would be regarding action, what the machine learning for artificial intelligence is moving by now.
Yeah, I think regarding the actions, it's of course key. So if you have learned things with the machine learning, so you say basically this is what comes out, and so you basically predict something with a 89 or 98% likelihood, yeah, so that you then implement this within your process, of course. Yeah. But this is not, that implementation then in the process is basically a different technology that you use. So you have the machine learning algorithms only giving you like a likelihood of what is the outcome of that, or what they see, what is a pattern in that data, but then what you do with it is basically the next step.
For me, it's not like that, to be honest, because it's, we are considering action, perception, and learning. It's the kind of thing. You need to act in order to perceive and to learn. And this is the kind of thing. We don't have, for example, as a human, we don't have just a learning. You need to, for example, to act. For example, press is on, you know. Then the object moves, then you learn how to move the object. You know, if the friction is high, then you know how to, for example, go, push with more.
I mean, what I'm saying is basically this is not happening in that from that machine learning algorithm. So the machine learning algorithm can give you a likelihood of what you should undertake, what action you should undertake. But that action is then done not by that algorithm, but it's performed by a process, automation, or what. And this is how I'm saying that. Of course, it's key that you do the action, yeah? And it's key that you implement the AI within your process. Yeah? I think that I see this as a bit of the next step. Any other question? Thank you very much.
Thank you.
Guys, we would like to thank all the sponsors and participants and the speakers for attending MI Summit, the one and only free event in Munich regarding artificial intelligence. It will become even bigger for the next years because we believe that the science should be hip and free.
Yeah!